Alright, so this is the continuation of Pre-Calc 11, Chapter 5, Section 2. It says multiplying dividing radicals. This section is actually pretty easy. And the way we begin is, notice that this says 2 root 5 times 3 root 5. We have coefficients of 2 and 3. We multiply the coefficients to other coefficients, and then the radicals with radicals. So we have what looks like root 5 times root 5. Essentially what that works out to is 2 times 3, well that's just the number 6. Root 5 times root 5, well you can actually write them as a single product underneath the radical symbol. And notice that we have a mysterious index. We know that anytime there's a mysterious index or no index at all, it's the number 2. And that says, hey, do we have two identical factors? And we do. So we can pull those two out and replace it with one on the outside. So this becomes 6 times 5, which is essentially, oops, my handwriting is terrible, 6 times 5, which is the number 30. Okay, so in general, I'm going to try to write inside this little box, but if you have a coefficient of m with a radical a with an index of k times n radical with the exact same index k, the radicand is b, all you do is you write the coefficients in front, they become a product, times, and it's the same index, a times b. And of course, in the previous lesson, you know that if it's possible, if you can factor, prime factor a times b, and you look for multiples of k, you can simplify a radical. Alright, so we're going to try a couple of examples real quick here. So here we have 5 root 3 times root 6. It's actually 5 times, and there's a coefficient of 1, so that's just 5. Root 3 times root 6, well that's actually root 18. But can we break down 18 down, and can we find two or identical pairs? Well, yeah, the number 18 is actually 3 times 3 times 2, so we have a pair of 3's which we can pull out. So that becomes 5 times 3 root 2, and that becomes 15 root 2. And again, I apologize for my handwriting. Moving on, we have what looks like negative 2 root 3, negative 2 root 11 with an index of 3 times 4 cube root of 2 minus 3 cube root of 3. Well, we know we can distribute. I always draw the lines. And let me just blow this up so we can see this. So this becomes negative 2 times 4. That becomes a negative 8. We have the same index. That's important. It has to be the same index. And then this becomes cube root of 22. So negative 2 cube root of 11 times negative 3. Well, that negative 2 times negative 3 is positive 6. And then we have the cube root 11 times the cube root of 3. That becomes the cube root of 33. Now, generally what we would do is we would try to see if we can add these radicals together. Are they the exact same radicals? No. If they were, you can just add the coefficients. So we are done. That's it. And normally we put boxes around these answers. Okay. The next example. 4 square root of 2 plus 3 times square root of 7 minus 5 root 14. We distribute, just like in a previous chapter. When we multiply binomials, we multiply the first terms, and then the outside terms, and then the inside terms, and then the last terms. So I'm just going to quickly do this. 4 square root of 2 times 1 square root of 7. The coefficients multiply. That gives you 4 square root of 14. 4 square root of 2 times negative 5 root 14. That becomes negative 20, right? The coefficients multiply. And then 2 times 14 is the square root of 28. This, I think we can simplify. Anyways, moving on. 3 root 7. Oops. Just ignore that. 3 root 7. Sorry. 3 times root 7 is just positive 3 root 7. And then 3 times negative 5 root 14. That just becomes negative 15 root 14. Now, again, I have a root 14 here and I have a root 14 here. We can combine those terms together. But let's just take a look at the square root of 28 here. I believe the square root of 28 is 2 times 7 times 2. So it's 2 times 2 times 7. Is it? Let's take a look. 14 times 2, that's 28. And then that's 2 times 7, and we have a pair of 2's, so we can we can group the 2's out because my index is a 2, right? So we can group these a pair of 2's out, and what are we left with? Well, we have 4 root 14 minus, if we group these 2's out, this becomes negative 40 root 7 plus 3 root 7 minus 15 root 14. Now these, because we have the same radicals with the same index, we can combine these two terms together. So this is negative 40 plus 3. That becomes negative 37 root 7. And then 4 root 14 minus 15 root 14, that becomes negative 11 root 14. And then we're going to put a box around that. Okay, so this will end this first little bit of this video. We'll continue on the rest of the examples in the next video.